How's it going, everyone? Today we're going to be making this fun little Unity plus OpenCV project. So what we've got here is a live webcam feed, and we're using OpenCV. That's Open Computer Vision. That's a library. We're going to use it to detect objects in the scene in real time, and then use the Unity physics to make things bounce off of it. So here's the setup. Basically, I've taken just a normal webcam, and I've got it kind of suspended over just a blank whiteboard, and it's that way the camera just has a blank white background to look at. So here's a little detail of how I jury rigged it. I've literally just used some baling wire and stuck it to a clip light. So to get going, we're going to start a new Unity project. So I'm over here in Unity Hubs. I'm going to say new project. I'm going to make this a URP. That's the Universal Rendering Pipeline. And it's just nice for this sort of thing. I'm going to put this here. And we're going to create the project, and then that's going to take forever. All right, so here we go. We've got the basic URP sample scene in here. And the first thing I want to do is bring in the OpenCV library that we're going to use. So to do that, I'm going to head over to the Unity Asset Store and search for OpenCV. There's a couple options on this one. So there's a paid version here, and honestly, I haven't tried it. I'm using the OpenCV plus Unity one. It's free. It does say that it's no longer supported, and I don't know if that means they're not doing development. But in any case, it's using OpenCV 3, and for me, it seems to be working just fine. So I'm going to say open in Unity. That'll bring up the package manager over here, and then the first time you do this, it'll probably say download, and then you can say import. And this will take a second, but we'll bring in the library, and then this will be all the stuff that we need to actually use all the OpenCV fanciness. Okay, so I finished importing, and the first thing to note here is that there's some red text down here. So that's an error message from the console. And you can see here it's got all these error messages saying unsafe code may only appear if compiling with /unsafe. So what that means is that the OpenCV library uses what's called unsafe code, which does sound a little bit terrifying when you get right down to it. What it means is that it's using basically C++ libraries in the background to do unmanaged code, which it kind of needs to do to be able to do the computer vision stuff quickly, perform it. So what we're going to do is go into project settings, go to the player tab, go into other settings, and if we scroll down far enough, we should come here where it says allow unsafe code. And if we check that, it'll act like it's not doing anything, but here in a second it'll pop up and start recompiling. And now all our error messages are gone. So next we're just going to get a kind of a basic scene set up just so we have something to work with. So I'm going to go up here to File and go to New Scene. We'll just do a basic built-in scene. Alright, and over here, well actually, so we're going to save it first just to get that out of the way. Say scenes, and I just like to call my scene main, but call it whatever you want. Alright, so now we've got a scene. We can right click here, and we're going to add a UI raw image. Okay, so this raw image, this is the thing that we're going to actually be displaying the video feed on. And you can see it added a canvas, a raw image, and an event system. This is using Unity's UI stuff. So it comes with a little bit of extra things. Just to get it set up in a spot that we can work with it kind of nice. I'm going to change the render mode over here into world space. I'm going to zero out its position and set its width and height down to 10. And I do this just so that we get something that's a little bit more manageable in size. Alright, so other than that, our raw image here is going to come out huge. So I'm just going to initially change its position back to 0 and change its scale down to 0.015. And I just discovered these values by playing with it. But this gives us an image and we can put some crap on it. Alright. So, now to actually, we need to do a little bit of coding here. So let's look down at our project view here. When we imported OpenCV, it brought in this new folder and made some stuff, but for our purpose here, we're going to go over to the scripts folder, right click, go to create, and make a new C# script. And I'm going to call this thing contour finder. I don't know, doesn't really matter. We're just going to call it something. So once you do that, Unity will rebuild, and I'm going to add that to our raw image here, right? All right, so I'm going to double click on that, and we're going to bring up Visual Studio or whatever code editor you happen to like. Okay, so let's just get rid of this bit of code here. So normally our scripts inherit from mono behavior, but for this one we're going to inherit from Webcam, which if you hover over it, you see we got this red squiggles and it says it doesn't know what in the world we're talking about. So if we right click on it, or I'm sorry, yeah, right click on it, or hover over it, sorry, and then use this little drop down over here, we can say using OpenCV sharp demo. So basically, this webcam class actually comes from the demo code. And if we hit F12 on that, we can actually see it inherits from mono behavior. So it's just adding some extra stuff for us to make this a little bit easier. So we can see that moves the red squiggly over here, and it says Contour Finder does not implement inherited abstract member webcam process texture, blah, blah, blah. It just means that that's an abstract class and it wants us to implement some stuff. So again, we can hover over this thing and say implement abstract class. That gets rid of the error message, and now we've got something to work with, right? Okay, so basically what it is this web camera thing. Basically, it'll take care of setting up the camera, and it's just asking us to do the processing that we want to do. So gonna delete that, and we're gonna do just a real basic setup here, just to get the camera going. So the first thing we're going to do is make a matte, which is a material. And again, this is a, get the red squiggly and it says we can't be found. So I'm going to click on that and say using OpenCV. So matte is kind of OpenCV's image texture. A lot of stuff revolves around that. Like, we're going to do pretty much all our operations on this this matte, right? All right, so first thing we got to do is say image equals OpenCV sharp dot unity texture to matte, and we're going to use the input. All right, so we're passed in the input from the web camera. So that gives us a material that we can work with. So normally we're going to do cool processing stuff on it, and then we're going to output it. So we've got an input, and this thing's responsibility is to get something into the output and return a boolean, right? So we're going to say if output is equal to null, then we're going to do this. We're going to set output is equal to matte to texture. So basically what this does is this image that we made up here, it's going to convert it from a matte to a texture, and texture being Unity's version of a texture, and we're just setting the output to that. So we're only doing this once though, just when the output's null. Otherwise, we want to do this a little bit differently. That same method, the matte to texture, actually has an overload, a second one here, where we can specify the texture, and then it'll just, instead of making a new image, or sorry, a new texture, a new object in memory, it'll just take the stuff from the input image here and dump it into that. This is kind of important from the standpoint that if you just do this every time, it'll work. Like you'll see the image on the screen, everything will seem fine. But the problem is you're allocating a new object in memory every frame. And if you bring up your task manager and you look at your performance, you'll see that your memory is slowly starting to creep up until you run out. So with this, it just means we initialize it once, and then from that point on, we take the image and just shove it into the already existing output. Okay, cool. Wrong on. So we're gonna save this. Oh yeah, sorry. One last thing is we have to return true, and that's just this function's way of telling the web camera we did indeed do something. So yeah, you have to return true from this function to get it to update the image. If you return false, it'll just act like nothing happened and not update the image. Okay, so we can save this. We've got no more error messages, and we've got some basic code that just takes the input image, converts it to something OpenCV can work with, and then outputs it back, right? So if we go back into our tutorial here, we'll get our compiling thing. And if we hit play, hypothetically what we should see is, well, sorry, let me drag this game view down into this corner just so I don't have to look at it. Hypothetically what we should have seen is the webcam view here. But again, we've got some red error messages down here. And you may or may not get this error message. For me, it says, could not find specified video device. So I can see that that's actually coming from that web camera class that we were using. So I'm going to double click it, and that'll bring us into the code where it started having problems. To me, it looks like this thing is trying to find a front-facing camera, which is all cool. But for me, it didn't work on my computer. So I looked at this code a little bit, and I just decided to set camera index to 0. Right here inside the if statement. Basically what this will do is just say find the first webcam that's attached, and we'll just use that. Okay, so save that, go back into Unity, and we'll see if that fixes our problem here. Oh, let's see, we do have an error message here. It says variable surface of contour finder has not been assigned. Yes, all right. So what that's complaining about is our contour finder, it inherited the surface property, and we need to set it. And it's just asking, where does it want to put the image? So we're going to take the raw image and drag that, the raw image from the hierarchy, and drag that into there. And now if we hit play, we should see this. Let's see if that works. Alright, so if we zoom way out, we'll see that we've got our image, right? Woo! That's our webcam feed. So it's way too big though. So I'm gonna take this and scale it down to something like this. I'm just gonna do 0.015. To be honest, I thought I already did this, but alright. Actually, I'm going to exit play mode and then set the scale to 0.015. That way it saves it. Okay, cool. Cool. All right, so here we are. We have a basic scene. So in the scene, we just have just a raw image, and it's taking in our webcam feed, uh, which is cool. So that's what we need to get ourselves to a point where we can actually do some of the fancy image processing. All right, so the next thing we want to do is we want to start processing this image, right? So I'm going to go back to Visual Studio and go to our contour finder. And what we need to actually do here is we need to get ourselves to a point where we have a solid black and white image that we can use to kind of trace out the stuff that we want to interact in the scene. So to do that, we're gonna add a little bit of code here, and just to get ahead of the game, I'm gonna add some variables that I know we're gonna need. So I'm gonna add a flip mode, and this is an enumeration, an enum that lets us. That's not a fun way to say it. Basically, it'll let us flip the image back and forth if we need it. When we do our black and white image, we're going to end up doing a threshold where we say everything below this value is black and everything above it is white. But I'm setting this up as a serialized field so that we can edit it in the inspector, and that'll be useful later. Let's see. And then we're going to use this as a little checkbox, just so we can decide if we want to see our processed image, which is kind of ugly, but it's useful for debugging, or if we just want to see the original image. All right, so since we saved that, if we look at our raw image in the inspector, you can see that we got a couple new fields here. We got image flip, which basically lets us flip it over the x-axis, the y-axis, or both. So we'll just leave that alone for now. The threshold, we just set up a basic value, but the thing is we can change it, right? We can slide it around, and that'll be useful here in a second. Other than that, we just have a checkbox for showing the processed image, right? Okay, so now to actually do something with it. So the first thing we want to do is CV2, and this is the computer vision library, and it's got most of the stuff we need in it. So we're going to say cv2.flip. And that's what we're going to use to flip the image. So you can see on the parameters it's wanting the source and output and the flip code. So we're just going to give it the image that we already have. We're going to output to the exact same image. So it's going to read it and write it to the same spot. And then we're going to use this image flip variable that we made. All right, let's see. So next we're going to convert color. We're going to say take it from the image and stick it into the, no, sorry. I actually need to add one more variable up here. So process image, this is going to be the image that we'll do most of our work on. We're going to have to do a few steps to do our processing. So we're just going to use this one image and reuse it. All right, cool. So convert color, the next thing it wants to know is conversion code. We're going to change it from BGR to gray. And what this means is the image that comes in is actually in BGR format, which this just refers to like the image format, like the order that the bytes are actually in. It's not super important to know, just know that that's how it comes in. And then we're converting it to a grayscale image because we're trying to get to that black and white thing. So next up, we're going to do a threshold. And we're going to take the process image, and we're going to write it back out to process image. And then for our threshold, we're going to use our threshold variable that comes in from the editor. The max value, we're going to set it to 55, and that's just, that way the threshold values actually come out as full white. And lastly, our threshold type, we're going to set to binary invert. So the next thing we want to do is where we're outputting the texture. I want to use this show processing image flag. So I'm going to say show processing image. I'm going to use a ternary operator. And I'm going to say, well, if we want to show processing image, we'll use the process image. Otherwise, we'll use the image. So we'll do the same thing here. So this expression here, this part here where it says show processing image, question mark, and this and that. If you're not familiar with it, this is a kind of like a little compact if-else statement. So we're saying if this thing is true, and you can write whatever expression you want in there so long as it evaluates to a Boolean value, right? So if this is true, then return this. And if it's not true, then go to the other side of the colon and return that. So for our case, if we're going to show the processing image, then we'll use the process image. Otherwise, we'll use the original image. Okay, so what we've done here is we've added a little bit of code in here just to flip the image based on the flag, convert it to grayscale, and then run a threshold on it. So I'm going to save that, and we're going to head back over into Unity. And we'll hit play. Okay, cool. So you can see now, I'm going to go ahead and change my camera view to orthographic and then just head in. And then also the grid is kind of annoying at this point, so I'm just going to change the opacity on the grid all the way down. Okay, so you can see now we've got a grayscale image, right? And so let's take a look at these options. We put in image flip. So if I flip on the Y or on the X or the XY, that basically just lets us move it around to what we need. The next one was threshold. And you can see if I move this down, less and less of the image is turning white. And if I go too far up, then everything will turn white. So the trick here is to find something where the background isn't turning white, but your object that you want to track is more or less turning white. It doesn't have to be 100% perfect, but the closer the better. And next up, we just have this flag here, so we can toggle between seeing the process image versus the original image, right? So that'll just be handy for us. Okay, so we've got an image, and it's kind of ready for us to start trying to find the actual objects in it. So that's what we're going to do next. We're going to add the actual magic here. All right, so after the threshold here, we're going to do CV2 find contours, and this is the magic. So this is a function that will look at the image and it will find the outlines of things. So we're going to give it the process image, and it wants to know a spot to output our contours. And if we look at the second overload of this function, we can see that it wants to output a point array of arrays. So you can see the two square brackets here, or sets of square brackets. That's an array of arrays. So what that means is basically we're going to get, for every shape that's in the scene, we'll get an array of points. And those points will be kind of the points along the outside. So we do need a variable to store that stuff in. So I'm going to come up here and say private point 1 array, 2 array, and give it that as a variable. So that way it has some place to put it. And I'm putting the variable up here. That way we don't have to reallocate space for it all the time. All right, so the next thing it wants is an output array, or sorry, a hierarchy index. To be honest, I don't really know what this is for. Maybe this is for holes or something. But we're just going to make a variable for it so that it will be happy. We'll give it to it. The next thing it wants to know is the retrieval mode. I don't actually know what this is. I just found it from the example. we'll use the retrieval mode contour approximation mode. Again, I just found this in the example. Okay, so now we've got an array of points, but the thing is, there's a ton of points. Like, this is the really tight outline of it, and it's going to end up being way too much detail for us. So what we're going to do is loop over the array of points. So we're going to say for each contour in contours, and we're going to use another approximation function. We're going to say point, give it an array, and say points. We're going to use this function called approx poly dp, and we'll give it the contour that we're looping over here, and it wants this variable called epsilon, and I'm going to loosely just call this curve accuracy. And this is basically how dense should the points be on it. So that one, that's something I'm going to want to discover. So I'm going to make a new variable up here called private flute curve accuracy. And I'm just going to give it a default value of, say, 10. Again, I just kind of discovered that value from playing around with it. But this is something we can adjust, and we'll see it in use here in a second. So the next thing is we want to measure the area of the shape, because when we look at our image and we get the threshold thing, we might have some noise. We might have some like really tiny little areas where it's just, I don't know, just a handful of pixels. And for those things, we don't want to bother with those. There's no point in including those in our simulation. So I'm going to use this contour area. I'm going to measure out the contour. And from there, I want to say if area is greater than some sort of minimum area, then I want to do some stuff with it, right? So again, since that's going to be kind of a value that we have to discover experimentally, I'm just going to put it up here and say min area, and then give it a default value of 5,000. All right, so now we've got a spot we can say, well, we found all of our contours, we simplified them, and if the area is over a certain minimum threshold, now we want to do something with it. And what we want to do, just to start off with, is we just kind of want to draw it back onto the image just so that we can see what in the world we're working with. So I'm going to make a new function here, and I'm going to call it draw contour. And I'm going to ask for the image that I want to draw onto, something called a scalar, which in our case is a color, thickness. And basically what it is this function here, I want it to take these points and draw it onto this image using this color and this thickness of line. So I'm going to add this over here. So I'm going to draw on the image, and we're going to draw it on the process image. We're going to, just for the moment, we're just going to say new scalar, and we're going to use a gray color. So scalar here is just a set of 3 values. The values range from 0 to 255. So 127 is right in the middle of that. So this is a gray color. The reason I'm picking gray is because our process image is a grayscale color, and we've got to use grayscale values. All right, so the next thing up is it's asking for the thickness. So we're just going to say 2, and then it wants to know the points. So we'll pass those in, and it's these points from the approximation thing. So this is the simplified thing. All right, so to actually implement this, we're going to say do a little loop that actually loops over each point in the array. We're going to say cv2.line, and what this will do is it literally draws a line onto the actual picture. There's actually a whole bunch of functions in here. You can draw circles and rectangles and draw text and all that sort of thing. which is actually pretty handy. But for our purposes, we're going to draw a line. So it's going to ask us where we want, what picture do we want to draw the line onto, and where we want to draw all the points from. So our first point of our line is points I minus 1, so whatever point we're actually on, and we're going to go to the previous point, and points I, and then we'll give it the color and the thickness. Which actually reminds me, I need to fix this. So instead of starting at 0, we're going to start at 1, and the reason is I'm basically going to draw a point from wherever we are at I previous to that, and then connect the 2 points. So we have to start off at 1 so that we don't, go to an index of -1 or whatever. Next up, we just need to close the line, so we're going to do one more line. I'm going to say points dot length -1 points. Okay, so what this is this one will connect every point 0 to 1, 1 to 2, 3 to 4, 4 to 5, so on. But the last line, we just want to close the shape, so this will go from the last point in the array to the first point in the array. Cool, all right, so let's take a look at that and see if it's done what we want it to do. So save everything, hit play here. All right, so you can see we've got outlines. So you see the gray outline around my hand, whatever. So that's cool. That's our thing. So the curve accuracy here, you can see right now when we have a value of 10 here, we've got a kind of a point here, and it's pretty low poly. If I move that down to say 5, you can see we've got a point here and here and here. So it's a little bit tighter fitting. And we can turn this down to say 1. And we get a really tight fitting thing, which is cool. When it comes to our colliders, the less points we have, the better this is going to be. So I'm just going to leave this at 10. And this minimum area thing, you can see we've got all these little white dudes in there. So if I turn this down to 1, it's hard to see, but we're tracing out all these individual little things, and you can turn this up. I found the values get too big to really slide through it. So basically we're trying to turn this up until we get to a point where we don't have traces around things that we don't really care about. But yeah, cool. So at this point, the computer now has the knowledge of the objects in the scene and kind of where they exist in two-dimensional space. So next up, we actually get into some of the fun things where we're going to add the physics. Okay, so let's make a basic physics thing. So we're gonna skip out of the code for a moment, and we're just gonna set up kind of a basic physics thing in Unity. So I'm gonna right-click over here in the hierarchy, and I'm gonna add a little sphere. All right, so. And so we've got a sphere in the scene. Woohoo! All right, so right now, it's not going to do much of anything. What we want to do is get this into the 2D physics that Unity's got. So to do that, I'm going to take off the sphere collider by hitting the little 3 dots and saying remove component. The reason I'm doing that is the sphere collider is a 3D collider, and we actually need one of the 2D ones. So if I go to physics 2D, we can see we've got a circle collider 2D. And the big thing is that this is in the 2D system. So that'll give us a collider, and then also I want to add a rigid body. Cool. All right, so if we hit play on this now, we should see that this ball just kind of falls down. Woo! Gravity's taking it, and it's just going down. So obviously, we want to give it something to bounce off of, right? You know, that's the whole point of this. So we're going to add a new game object. We're going to call this our collider. And I'm going to reset its position to 0, 0, 0. And while I'm at it, I'm going to set this thing's position to 0. Alright, so back on our collider here. For the physics, the 2D physics, what we want is a polygon collider. So we can see that while we've got this thing selected, we get this little green outline, and that's the shape of our collider here, right? If we deselect it, it'll disappear because it's just kind of a helpful indicator for us. But in any case, so it looks like when our ball drops, it probably should hit that. So let's go ahead and hit play. Woo! It bounced off it, which is cool. That's actually just what we want. One thing though is I want my ball to be a bit bouncier. To me, that seemed a little flat. So I'm going to introduce a physics material. All right. So in my assets folder down here for the project, I'm going to right click and I'm going to say create 2D physics material. And I'll just call this ball. And if we look at that ball in our inspector, we've got two properties, friction and bounciness. So I'm just going to turn that up to 0.8. And then this material, I'm going to apply it to our sphere. So there's two spots. We can put it on the collider, but I think for the 2D stuff, it makes better sense to put it on the rigid body. So I'm going to hit this little circle on the side and select the ball that we just got. So now, if we hit play, what I expect to see is the ball bounce quite a bit more off of the thing when it hits. Woo! Cool. Right on. So that's kind of our basic system, right? We've got a rigid body inside the system, and we've got a collider, something for it to hit. Now, the reason it looks like this this pentagon is because of the points. So this polygon collider, you can have multiple paths, and each path can have multiple points. So we've got one path, which is to say one shape, and we've got 5 points. And if we move, say, the point around, you can see how it changes the shape. So for us, the trick is going to be, instead of us manually putting these shapes in, we want our actual code to go and set these properties. All right, so we're going to go ahead and bounce back into our code over here. We're going to add a new variable for that polygon finder, right? Or sorry, the polygon collider. Let's see, what do we call this thing? So this will give us a reference to that that collider so that we can actually do some stuff with it. So I'm going to go ahead and save this, flip back over into Unity, and we'll see that on our contour finder here, we've got a new spot to assign what collider it should work with. So I'm going to hit the little button. And I'm doing that now because I just too often forget to assign it. Then I go hit play, and then I get null reference exceptions, and it's just a bad day. All right, cool. So our business here is now that we've got our polygon collider. We know our shape. We've got all our points. Now we just need to actually assign it to that thing. So the first thing I want to do is, before we get into our loop, before we're actually looping over all the shapes we found, I want to say, hey, polygon collider, your path count is 0. We're just going to assume that there's nothing in the scene, there's nothing there for us to work with. Then we're going to get into our loop. We're going to loop over each object that we find, and we're going to approximate it and measure its area. And if it meets our basic requirements, what we're going to do is we're going to add it to that polygon collider's paths. So we're going to say path count plus plus. It is, okay, you've got one more path than what you had before. Initially, you had none. Our first one we find, now you've got one. And if we keep finding them, we'll add to it, right? All right, so polygon collider, set path. And it's going to know which path do we want to set. So we're just going to say, hey, the last one. And I'm saying -1 because it's actually an index. And in code, indexes start at 0. All right. So the next thing it wants is vector 2. Now you might be inclined to say, well, we've got our points here, and these are the points that we want. but these are something called a point, and it wants something called a vector2. All right, so here's the thing. Vector2 is Unity's representation of a 2D point, and point is OpenCV's representation of a 2D point. It's basically the same thing, but they are two different classes, so if you just try to pass in points, it will yell at you. It's going to say, I can't convert from a point to a vector2. What are you talking about? All right, so we're going to help it out. We're going to make ourselves a little helper function here. We're going to say, make a little function. It's going to return this array of vector2s, and it's going to take in an array of points. So basically, we're going to put in the OpenCV points, and we're going to get out Unity points. So this isn't anything complicated, but it's just something we've got to do. So one thing we want to do is up here, we're going to say, make ourselves a list of vector2s. And we're going to initialize it to a new list of vector2s. And the size of this is going to be the exact same size as the points array. Right, so the notion here is if we've got 20 points in this array, then we want our vector list to have 20 points. Then we're just going to do a loop. So we're looping over every point in the points array, and we'll say in our vector list, in slot I, is a new vector2, and we're going to use points I.x and points I.y. Okay, so nothing too complicated here. All we've really done is we've made a new list that's the same length as that, and then we've looped over all the points and just made a new vector2 and shoved them in there. Okay, so now we can go back up to our set path, and we can make this guy happy. So we can say 2 vector2 points. And this will just, convert it over to a format that it knows what it's talking about. All right, so that's cool. That wasn't too bad. Let's see if that worked. Yeah, I saved it. Okay. So I'm gonna just hover over, or I'm gonna click on the collider just so I can see what shape it's got, and then I'm gonna hit play. And hopefully, what we're kind of expecting is that these shapes would have shown up outlined in green, but they're nowhere to be seen. So here's the problem. If we zoom way out, we can see, oh, there's our shapes. So like that's me putting my hand in the scene. So as I say, it's freaking huge by comparison, and the reason is the points that we're getting in, those are like actually the pixel values. So like this is say 600 pixels up and 400 pixels wide, and in Unity terms, that's 600 meters up and 400 meters out. So as I say, it's just huge, and all we need to do is just change the scale to fix it. So I'm just going to scale it way down and then hit F to fit it. And I'm going to keep scaling this down till it's, something that I can deal with. Okay, so the next thing I've noticed, for me, my this looks mirrored. So my little pliers there are kind of pointing down to the right, and this guy's pointing up and to the right. So we could do this different ways, but for this, I'm just going to make the collider match. So for the scale, where it says Y, I'm just going to put a negative value in there. And now we can see that our pliers are facing the same direction. They're offset, they're not in the right spot, but at least they're pointing the right way. All right, so next up, I'm going to change the position. I'm going to move it so that the position of the thing is literally right in the top right corner. And we can see our green outline is pretty close to our gray outline. It's not quite right, but it's getting close. So next up, I'm just going to change the scale until it lines up. So it's hard to see, but we've got our little green outline. So this now is, instead of drawing on the picture, now we've got a collider that's actually in the the world space of the scene. So now this is truly the magical spot where we've gotten Unity to actually be aware of the those shapes and terms that it knows what to do with. All right, so the thing to know here is we're in play mode, and we went and changed the transform on this object. And if we exit out of play mode, Unity will do its normal thing, and it'll just erase everything we just did. So to get around that, I'm going to right click on the transform, and I'm going to say copy component. All right, so I'm going to put all those values on the clipboard. And you see when we exit, all the values went back to where they were. So that's lame. We're going to paste component values, and that gets us our values back. So that way, if I hit play again, we should get right back to where we were. And look at that. Now our ball actually responds. And I can dump the ball out. Which, I mean, come on, how cool is that? So at this point, this is really the crux of the project. We've done all the stuff we really need to do to conquer the big problem. We've made our we've imported OpenCV, we've processed our image, and we've made our collider that responds to the actual image. But you know, it's not that fun. We just had the one ball, and now it's gone, and you know, now we're lonely, right? So what we're gonna do is, to make it actually get closer to what I showed at the beginning, we're gonna add an emitter sort of thing. We're just gonna make a million balls kind of come down from the top and bounce around in the scene, and then once they get down to the bottom, we're just gonna kill them off so that they don't spend all day falling, right? So here's how we're gonna do that. I'm going to make a new 3D object. I'm gonna make it a quad. I'm gonna call this thing the emitter. It's facing the opposite direction for me, so I'm gonna rotate 180 degrees just so I can see it, and I'm gonna zero its position out just so I'm kind of starting in a known spot. And I'm gonna move it up here kind of above the scene. I'm gonna scale it out. So basically, wherever we have our gray box here, we're gonna pick, when we emit points, we're just kind of gonna pick a random spot kind of inside there. The one thing I am gonna want to do is I'm gonna set the Z scale to 0 because I don't want it to having depth. Okay, cool. So let's make ourselves a new script, and we're gonna call this script emitter. And Unity's gonna recompile. And I'm going to add that script that I just made onto our emitter object. And then I'm going to double click it, and then I'm going to open up the script, right? So we don't really have to go into too much detail on this, but here's what we got. We need some parameters for this thing to work with. The first thing is we need a game object to spawn, right? We want to make a million of these little particles falling down. It needs to know what that object is. So we'll give it a reference for a prefab. We also need to know how fast we want to spawn these things in at. Let's see. Next up, we want to know what the maximum amount of particles is. We're going to start off with a low number, and we're just going to say the most particles we can have in our scene at any one time is 3, which is a ridiculously small number. But when you're making emitters and going to make a bunch of objects, it's better to start small and make sure your stuff is actually working before you go big, right? The last thing here is I want to make a size range. So for me, I want to make those balls, you know, some smaller, some bigger. So a vector 2 just gives me 2 numbers, and I can say, okay, between the small value and the big value. Other than that, the way I'm going to do my object, or my emitter here, is I'm going to have a pool of objects. And basically, the notion here is that we could, every time we want to spawn a new particle, we could call instantiate in Unity, and that would make a brand new object, and that would work. The problem is that when you do that, you're making a new object in memory, and when you're making lots of objects, eventually that makes Unity unhappy. You've got garbage collection and stuff where you've allocated memory, and then, like, when you get done with it, it tries to get rid of it, and it all kind of just ends up being a pain. We know that we're going to always want a bunch of particles, so what we're going to do is use a pool of objects, and we're just going to say, well, I want our max number of particles. I just want to make those and have them around, and then I'll just turn them on and off when I need them. All right, so I'm going to make a new function called initialize pool, and then we're going to say pool equals new game object array max particles. So that's this variable, and we're just going to make an array that is this big. So for so we've got 3 particles, so it's an array that's 3 big, so we've got 3 slots. Next up, we're just going to fill them. So we're going to make int I equals 0, I is less than max particles. And here we're going to actually instantiate it. Instantiate means actually make the object. Like, take the prefab and make it and put it in the scene. All right, so at this point, this particle would be in the scene. We're going to set the active to false because we don't actually want to see it. We're just going to make it and turn it off just so it's ready for us to use it when we want it. And then other than that, we're going to put it into our pool. So we're going to say pool I equals particle. So all we're really doing is looping over every slot in our pool, making a new particle, turning it off, and that's it. That's the whole thing. So in our start function here, we're going to initialize the pool, just so that we've got it. And just so you can see what's going on with that, I'm going to flip back over here into Unity. So here's our emitter, and we've got our default values for some of the stuff, but it needs to know what prefab. And we want to use this sphere, but the sphere is not a prefab. So I'm going to create a new folder called prefabs. And I'm going to drag the sphere down into there, and then this makes the sphere into a prefab. And now I no longer need it in the scene. And in the emitter, I want to say, what object do we want to make? We want to make this object. So if we save that and hit play, what we'll see is it should make all 3 of those objects, so they're there. Spheres 1, 2, and 3. It made them, it turned them off, we can't see them, but they're there, right? If we turn one on, there it is. Woohoo! Alright, one more thing we should do is the emitter has this size range that we put in. So I want to say how big the spheres are, just kind of a range. So I'm going to look at my sphere and say, I'm looking at the scale here, say I want them to be kind of from, I don't know, about this down to about that. So down here is 0.25, and I don't know, about this big, let's just say it's 0.6. So our size range here, we'll just say it was 0.25 to 0.6. That way when we spawn these things, we're going to go somewhere in between these 2 values. Okay, now I really can't get rid of that sphere. Alright, so what we want to do is we want to have a thing that fires every so often, basically the spawn rate, and makes a new one, right? So we're not going to use the update function, so we're going to get rid of it so that Unity doesn't really have to bother calling that function. We're going to make a new one called spawn, and I'm going to call that from the start function. So when we start, it's going to call the spawn function, and what we're going to do is spawn the particle into the scene. And then, and here's kind of our trick, we're going to call the same function, spawn, after this delay. So what we're doing is we're calling it once, and then every time you call this function, it ends up calling itself again after this amount of time. And this is in seconds. So however often spawn rate is, so if this was 0.1, this would be every 0.1 seconds we'd fire this. And the reason I do this as opposed to, say, you could do invoke repeating, like this invoke repeating would do pretty much the same thing. The only difference is that if you change the spawn rate after the game is started, then it won't change. Like you call it invoke repeating and it's done. You could deal with it in various ways, but basically this way, whenever you're spawning the thing and you get to start it, we'll look at whatever the spawn rate is right at that moment, and that way it's easier to update. Sorry, tangent. All right, so the next thing we want to do is we want to look at our pool of particles, and we want to find one that is not already active in the scene, and we want to turn it on and get it going, right? So for that, we're going to say for each particle in the pool, we're going to check to see if that particle is active self. All right, which is to say, if it's not already active, then boom, this is our guy. This is the one that we want to mess with, and that's all we're going to do. So we're going to break. And now that we found a dead particle, one that is just sitting around being a slacker, doesn't have anything to do, we're going to use it, right? So we're going to say, hey, particle, transform position. So this is us telling it where it should actually be. And we're going to pick a value here, a random value. So inside unit sphere, this will give us a vector 3. So just, a position in the world that is somewhere inside or on a sphere with a radius of 1. I'm multiplying that by 0.5 because I want this to be a value that's somewhere between negative 0.5 and 0.5, because this rectangle up here, before you've scaled it, this side is negative 0.5 and this side is 0.5. Sorry. We're just going to go ahead and do that. And we'll say transform point. And basically, transform point will take it from this object's local space and move it into world space. So the reason I'm doing that is because this thing is stretched out and it's moved up and all that stuff. If I pick a random value that's somewhere inside its unit sphere, it'll just pick values in there. Sorry, I don't mean to belabor that point. Other than that, I'm going to set the thing's local scale. And for this one, I'm going to say a random range between cool. So local scale, that is a vector 3, and it's a vector 3 because we've got x, y, and z. For us, we actually want our sphere to scale uniformly, so all of those are the same value. So what we're going to do is we pick our random number and we multiply it by 1, and by doing that, we basically just convert this into a vector where all the values are the same. Cool. So now we've moved a particle into kind of a random spot. We've set its scale to something random. Last thing we need to do is just turn it on. All right, so let's take a look at that. So if we hit play, what I'm hoping to see is a few particles spawn out of here. Ta-da! And let's slow the emitter down, the spawn rate, to 1 per second, just so we can see that a little bit more clearly. So we hit play, 1, 2, 3. All right. So we've got our particles, but they're just kind of, they just stay in the scene and they're just there forever, right? Um, those two that fell off, they fell off and they're gone. And they're going down and down, 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 right? If we look at it, you can see the y value here is just going down. All right, so that's no good. Our scene is boring because the objects left us and they're not coming back. All right, so what we want to do is say something along the lines of, hey, once they get outside of the screen, just kill them. They're of no more use to us. So we're going to use basically a similar trick where we get to define this. So new 3D object, quad. We're going to say this is our kill zone. And I'm going to rotate it around, set its position back to 0. What I want to do is move this thing down here kind of off screen, scale it up so it's nice and big. And what I'm looking to say is that anything that goes into this zone, we're just going to kill that particle. Now, to do that, we need a collider on it. And because we're working with 2D stuff, we need a 2D collider. So I'm going to get rid of its mesh collider, because that's a 3D one. And I'm just going to say a box collider 2D. Cool. So that made a little green box around it. And then this is important. We're going to say it's a trigger zone. So objects don't bounce off of it. Rather, we just get a signal when they go into it. All right, so we need another little script here. We're going to call this thing kill zone. And we're going to add that component to our kill zone. And don't worry, we are almost done, I promise. Okay, so for our kill zone, it's really, really super simple. We're just going to get rid of these functions. And if we do private void on trigger enter 2D, make sure you get the 2D. That part's important. What we want to do is this will tell us any object that's any of the 2D objects that come into it, it'll tell us about it. So we're going to say the thing that collided with it, we're going to take that thing's game object and set it to inactive. That's it. That's the whole kill zone. So let's take a look at what that does. So this object comes down, and then as soon as it gets to here, it turns off. And because it's turned off, that means when the emitter goes to turn something on, there's something there for it to find. So that's cool. So let's crank it up, man. Let's go back to our emitter, and let's say we want to spawn pretty often. And instead of having 3, let's have 100. Cool. All right. So now we've got something we can work with here. And it's cool. Like this thing actually will fill up with this stuff, or we can bring an object in and they bounce off. And that's super fun. And the cool thing is the Unity physics system is actually pretty robust. So I'm gonna change these values around just a little bit. So now we've got 1,000 particles. Let's see what that looks like. Oh, all right. Well, so that's not spawning fast enough. Let's really, yeah, there we go. And just for fun, let's not look at the processed image. Let's turn that off. Turn off our gizmos. And look at this. Yeah. Well, I mean, that's it. That's all I wanted to show. I know I kind of droned on and on about it, but this is kind of cool. We've got a little Unity project where we've got a webcam coming in We've got computer vision thing, like actually looking at the scene and making our colliders, uh, so that we can have it actually interact with our world. And then the physics system doing what the physics system does best, and it's just fun. Cool. All right, with that, guys, I'm gonna say goodbye and good luck.